Windows scheduled tasks have burned more admin hours than I like admitting. One Monday, finance laptops missed a cleanup job before a software rollout. The task existed. The trigger was right. The script path was right. The GUI even said it was ready. But half the fleet was on battery, idle conditions were wrong, and one task had been hand-created by an admin who had already left. We did not have a task problem. We had an undocumented automation problem hiding behind a friendly wizard. The Task Scheduler GUI is fine for inspecting one box. It is a bad source of truth for hundreds or thousands. Clicked tasks drift. One admin chooses run only when user is logged on. Another stores a password. Another points to c:temp fix ps1. And nobody notices until an incident or outage. Worse, conditions like battery, idle, and network availability can silently prevent a run, especially on laptops. At fleet scale, the question is not, does this task exist on my machine? The question is, which machines have it? What identity runs it? What executable starts? Who authored it? And when was it created? The core move is simple. Define scheduled tasks as code. In PowerShell, a task is built from an action, a trigger, a principal, and settings. The principal matters because it decides the security context. For machine maintenance, use system when appropriate, with new scheduled task principal and no stored password. For domain resources, consider a group managed service account, or GMSA, so the password is managed by Active Directory and not typed into a script. Then export the task XML and put that XML under source control. My opinion, the XML is the contract. Here is the shape. Create the action. $action equals new scheduled task action, execute pwsh.exe, argument no profile file, c:program data, ops, clean logs ps1. Create the trigger. $trigger equals new scheduled task trigger daily at 3 a.m. For system, use $principal equals new scheduled task principal, user ID system, run level highest. That does not store a password. For settings, start with $settings equals new scheduled task setting set, start when available, then explicitly set battery and idle behavior if this will run on laptops. Register it with register scheduled task, TaskName, ops clean logs, task path, $ops, action, $action, trigger, $trigger, principal, $principal, settings, export with export scheduled task, TaskName, ops clean logs, task path, $ops, and commit that XML. Here is a real fleet scenario. Security asks, which scheduled tasks were created outside our standard deployment process last week? First, query creation events. Get-WinEvent-FilterHashtable, LogName security, ID 4698, StartTime and GetDate, AddDays -7. Feed that to your Security Information and Event Management Platform, your SIEM. Event ID 4698 is the security log record for scheduled task creation, assuming advanced audit policy has other object access events, success auditing enabled. Next, inventory tasks. Get scheduled task-sim session $servers. Select task name, task path, author, state, and expand actions for execute and arguments. Unexpected author or unexpected action path equals investigate that task. /users public, user profile paths, and unsigned scripts should all raise eyebrows. The first pitfall is believing registered means reliable. Conditions still win. A task can be enabled and still skip because the machine is on battery, not idle, asleep, or past a start boundary without start when available. Be explicit. The second pitfall is credentials. Do not store a domain admin password in a scheduled task. Use system for local machine work. Use a GMSA when the task needs domain access and the target machines are allowed to retrieve that managed password. PowerShell 7 works well on Windows with the Scheduled Tasks module, but this is a Windows module. It is not available from Linux. Windows PowerShell 5.1 differs mostly in default file encoding when exporting XML. Scheduled tasks sit right in the middle of administration. They use the object pipeline, common information model sessions, remote inventory, file permissions, logging, and change control. They also connect to group policy object preferences, configuration management tools, and endpoint detection. A task that runs as system is powerful, so treat its script path like a service binary path. Lock directory, correct access control list, review process, and logging. This is why we learn PowerShell objects before fleet automation. You are not just making a job run at 3 a.m. You are creating a small, privileged service. 10 minutes safe exercise. On your own workstation or a test virtual machine, run Get-ScheduledTask and sort by task path. Pick one built-in task and inspect it with Get-ScheduledTask.info. Then export one harmless task to XML. Export scheduled task, TaskName, task path, and save it without file. Do not register anything on production for this drill. Next, search your local security log for event ID 4698 using the snippet in the description. If nothing appears that is useful too, it may mean the audit policy is not enabled. Finally, look at author and actions. Get used to asking, who created this, and what exactly runs? Recap. First, Windows scheduled tasks scale only when you define them as code, action, trigger, principal, settings, and exported XML in source control. Second, choose identity deliberately. System has no stored password and is right for many local maintenance jobs. A GMSA is better when domain access is required without parking with human password. Third, audit what already exists. Unexpected author, weird action path, or event ID 4698 from an unknown process deserves attention. Tomorrow we keep building the administration tier with more PowerShell and Windows Fleet habits. New PowerShell episode daily on this channel.